Good afternoon, everyone. I'm Shailesh Mittal, and I've been with Datera for more than 4 years now, pretty much the time when we started writing our software. I'm with Datera, and today's session, I'm going to take a leaf from what Bill has been mentioning from modern data centers to talk about what the modern applications are. So basically, we're gonna gradually learn and improve our knowledge and learn together, basically, like what the applications in today's environments are looking for, what are the expectations are from the resources underneath, what are the frameworks available which are actually making these applications behave certain way, the way they are doing right now, and what possibly seems to be the future, and why Datera is the prime and probably the only choice which you should be making for some of the modern applications. So moving forward, the quick thing is, whenever we talk about applications, right, we also talk about the environment they run in. So what are the applications made up of? So applications are absolutely running across a lot of operating environments right now. So some of the applications are running in on-prem, applications are running in virtualized private clouds, applications are running in public clouds like AWS, Azure, what's or not. So the problem with these environments and the way applications have been thoroughly thought is like, before I design an application, I also think about where my application is going to run. So it means I have figured out an environment where this application is going to float in, and I basically go and say, okay, since this application requires X, Y, and Z parameters, and I'm going to run in this environment, so let me tune those parameters to suit it better for the environment where this application is going to run. So it means applications are customized for the environment where they run in. And then that basically presents a greater challenge that you have to worry about now your application moving from one environment to another environment because you have customized it so much, though the advantages are pretty obvious that I should move from one environment to another environment, but I cannot do so because I'm totally logged in. I'm totally logged in into one environment. So what should I really do? So the fundamental problem that comes in front of me, and how do I break this lock-in? And to break the lock-in, it means I need to rethink the way I have thought about my application. So it means the way I've designed it, if it is a single monolith, I need to change this monolith and break it into microservices. It means I do not need to see this application as a single piece running for eternity and doing every job one after another. I need to start thinking, what are the multiple components of the application? How can I break it into multiple pieces so those pieces can individually float in? When those components, what we call as microservices, they run together, they still achieve you the purpose of an application. So it means a little bit of redesigning what traditionally modern applications are doing. So if you take about applications like Cassandra, you talk about applications like MongoDB, or maybe Spark, maybe some of the applications run by Splunk. These applications are actually designed in such a way that they are not monolith. They have microservices. So the way they are thought through, they are not concerned about the hardware they're going to run on. They are not tied. They do not have any affinity to the platform underneath. What they need is, they need some resources to run. They are built for scale. So they start slow and they grow big. As and when the requirements come into the system, they start scaling out. And they are primarily built to handle the workloads which are very dynamic in nature. And that's where our interesting discussion come in whenever we talk about applications. When they are attached or they are having a strong affinity to the platform, they cannot abstract their resource requirements. So I cannot really say an application which requires a certain set of resources now, when it's going to grow or scale out, it will need the same set of resources because I need to think in the direction of physical resources in that way. And if, as an application developer, I'm spending more time in redesigning my application every time it scales, that's not going to work. So that's where we need an approach where application can abstract out its resource requirements, convey its message that what does it want to do without worrying about the physical infrastructure layout underneath. Now, other thing that comes up with modern applications is whenever we talk about multiple components working in parallel and doing things, application has to have an ability to recover from partial failures. So it means one of my component can fail. So it means my system has to be intelligent enough that I can resume my application by just resuming that component, and that component actually can join back the original state of the application. So it means my granularity of failure is towards the services. So individual services can fail, they can come back, they can resume the operation, and go and contribute back to the application. And that's how the whole system is designing. So this whole system is very, very dynamic. It's packaging everything together into a single system, which is your application. Now, why we are talking about this? So we are talking about this because today's frameworks, whenever we talk about
Sorry, maybe I'm jumping the gun, but is this leading to something like persistent storage and so on?
It is, but it is also talking more about why modern applications have been different with traditional applications. So if I talk about a real job, let's say if a bank which has deployed a huge, massive Oracle database, okay, and they have a requirement where they need to run 10 reports in the night, let's say, for generating various different type of data. Originally, when these jobs used to be thought of, they used to be thought in such a way that your application gonna be accessing a certain set of data.
Right.
They're gonna run a report on it. Then once the report is done, then we're gonna run separate report because it has to be run in a lean time where my real transactions are not happening. But since everything is partial, and if a report breaks in the middle, for some reason my workload drops, either I maintain a checkpoint in the system that how far my reports have gone through, or I start this report again. Right? So with the newer application, if you really see, if I break these components down into services, what I can do, I have the same data set. I can spin in these things into 4 different environments because I have the same data set. If my data set is available into multiple places without actually writing into the same thing, it means we are all working on the same copy without disturbing the original one.
Okay.
If my one report breaks in the middle and the environment is not good enough, I can always move this workload into somewhere else and run these things.
I see.
Right?
Sorry.
If
I understand all of this. It's the Terry whatever. Okay, maybe also on Wikipedia. The problem is, I have customers that are running applications in PLSQL and on Oracle, and I'm doing this thing. They are not going to, and this is the lucky scenario.
that's right.
Because they could have application written in COBOL, working on plain files and stuff, and still, they are not going to change them.
Absolutely.
Some of them. So my question is, okay, and they are also looking at containers. What I'm trying to understand when you say enterprise, I'm sure. So I want to see from your platform the best, let's say, benchmark on SAP on Oracle. That means very, very enterprise.
Right.
And then we can talk about modern enterprise.
That's
because alongside this benchmark, you can show me in the same system we can run containers and VMware and 75 other things, and I'm okay.
That's right.
But how build the application and how the modern applications are written. Okay, that's I don't know if that's the point of the storage.
You're trying to say that you need to be able to support both old and new.
Right.
Everything. So
Yeah.
I'm okay that containers are
So
the best thing of the world until you decide to do with Lambda functions.
Okay.
So just real quick. So as part of our continuing coming to the marketplace, we are in discussions to actually produce a performance white paper through a validated third party, specifically around the applications you just talked about. So that is coming within the next 2.5 months. But I think Shailesh will talk about this challenge of, I don't want to get into how crazy it is, but you have these legacy applications, right? Maybe they're running on Itanium. You have legacy applications. How do I monetize that, right? And the power of the Datera solution is that I can set a policy set where we deal with it and we make sure the availability is there, or we understand the application doesn't. That's the real trick, and that's what we're talking about.
This question, aren't we also talking about the choices, the decisions enterprises make as they're modernizing their data centers and the benefit that Datera adds to those modern data centers? I think that's the point you're ultimately getting at. So it's not about us in this particular section we're talking about selling against those traditional ways that some people are doing it that aren't going to change, but talking about the benefits of Datera when people have already made that decision that they are changing to this containers architecture.
Right.
And Shailesh is a containers and a Kubernetes expert, and so he has a bias. And we're interested to hear from you about what you're hearing out there about containers and about how people are handling storage in that case.
Quick disclaimer, I started my career with HP Labs. I built Titanium for 5 years before I moved to UCS and built UCS for 5 years and then moved to Datera. So I completely understand
Maybe
that
I'm wrong, and maybe as always happens in the Silicon Valley, everything is, through 3 years ahead, 4 years ahead. But when I talk to enterprises in Italy and across Europe, containers are still a niche.
That's right. I completely agree.
So that's what I want to say. So it's very, very important. So supporting container is a feature of a storage system. It's
Right.
It's not you can base a storage system on supporting only a single operating system or a single technology.
Absolutely.
Because we saw in the past that all the companies that did it failed.
We share that philosophy. This supports bare metal. Bare metal's back, right? We just don't call it physical servers anymore, right? It supports VMs in any whatever form and containers, and you don't choose one versus the other. It supports them all simultaneously. So companies are in some form of move. Maybe they're not in form of move, but most of the companies that are evaluating us are coming towards this direction, and they're trying to move away from it. But we agree. If you're a one-trick pony, you're done.
Okay, good.
Right. So basically, to summarize very quickly, so point is not here that every application which is out there is a modern application, which basically has to break its component and do things. I understand, like, majority of the applications that will be running in enterprise world would be legacy applications, and we work great with them. So I'm going to cover that a little bit ahead in my presentation when we literally talk about that why we can work across the spectrum of the flavor of application, whether it's application which is fairly aware of its needs versus an application which do not, or basically chose not to basically spend time in figuring out the resources that it needs. So we work across the spectrum, and we fit in well with either kind of those. Why I introduce the topic of container here? Because the kind of requirements that we just talked about, that is a part where a world where container can run together and like multiple containers can float in, and they can complement the services model that we just talked about, microservices model rather. Containers fit in very well.
So Kubernetes containers support both block as well as file?
They have multiple
objects?
multiple level of support. So it's a file, it's a block. They support. I haven't seen a vendor supporting object along with Kubernetes yet, primarily because of the kind of applications maybe running in, but that doesn't stop anybody to not support objects.
You guys are only block and object at this point?
We are, at the moment, we are block and objects. That doesn't stop us adding anything into our umbrella, be it a file or anything. We just are weighing our options, we are evaluating everything, like when we should start. And for us, the way our system is built up from grounds up, we have like two parts of our system. One is the data management part, another is the data projection part. Management part is a very standard part, like how do we place the data, how do we mark the data available, and how do we handle the storage resources. The data projection part is basically how do we present this data to the users. So it's a block presentation, or it's a file presentation, or it's an object store presentation. That is something that we can churn out very fast because we kept these layers very independent of each other. And they are strongly basically implemented using the factory methods. So basically burning a factory to give another level of projection is super easy for us. So we are working on it. I think soon you're going to hear about more and more data projection and the data presentation that we're going to have. So why containers? Containers are very efficient. They are faster to provision, deploy, and they scale up pretty rapidly. The quick part around Kubernetes, as you touched earlier, Kubernetes is a de facto name for containers. Right now, whenever a lot of people talk about containers, they presume Kubernetes or Kubernetes and containers are very synonymous, as it used to be with the Docker. So Kubernetes, so I'm not sure like how savvy audience is with Kubernetes. Are you guys very familiar with Kubernetes, what Kubernetes does? So I'll still spend like 10 seconds quickly on Kubernetes. So Kubernetes is a very strong mechanism to provide you container-centric management. Kubernetes has a way of representing applications through pods. Pods are nothing except a bunch of services running together, and each service is a container.
So you guys support CSI now? Or
We do.
So you have support for CSI?
So we have CSI. We start with Flex. Flex is GA. CSI just got GA. So we have our CSI version out, and as CSI is getting mature to be deployed in the real world environments, we are ready. So we're going to talk about like how do we handle some of the nuances of these frameworks by terminating the storage back on Datera side, because you can shield yourself from some of the shortcomings of Kubernetes. Coming back here,
Shailesh, you're way too modest about your involvement in the container world, please.
it's okay.
Okay.
So
He was
the
there
part.
at the beginning of all this stuff.
So I've been with Cube 6 storage group right from its inception. So we designed a lot of things like how the storage world should look like, how the Kubernetes storage should be presented, how the templating mechanism with related to storage classes and other things should happen. And that was the same time when Datera was also implementing its policies and templates part of it. So we heavily influenced some of the designs in Kubernetes. So I'll give you a quick analogy here in our next slides, maybe like a couple of slides, where we talk about how you can basically abstract out your usage. And that's where I'll be able to answer some of the questions that have been raised earlier with legacy applications versus modern applications. So quick 101, what is a Kubernetes pod? It's pretty important for us to get familiar with this term. A pod represents an application. An application has multiple components. Each component is running as a container, let's presume this way. Pod is packaging all these containers together. So when a pod gets instantiated into Kubernetes, it runs all those containers into a single host. So it means if anytime one container fails or application fails, whole pod moves. It means whole set of container moves. Now this is true for any application, whether it's legacy or modern. But the failure management is handled by Kubernetes itself. So it means the framework is getting intelligent with respect to maintaining application lifecycle. So users need not worry about it. Now, the important piece that comes along with application provisioning is an application can be smart. An application can really think about how it's gonna ask for certain resources. But is your storage platform or your platform for providing resources smart enough? So it means if application is ready to provide you some hints, are you able to consume them? So in typical environment that we've seen with Kubernetes or other environment even, there is a certain way you can pass some of the labels and hints down to the framework by labeling the way your application works. Now, what we call is as an intent. So an application can say, okay, it's a performance-heavy application, like it wants more performance out of it. Or application can say, okay, it wants more protection. So I want to have more snapshots, or I want to have some automated backup mechanism. I can say, okay, I want this application to run only in an environment where I'm not sharing resources with anybody else. So I can say, okay, I have some isolation semantics. I can say, okay, this application works on a data set which actually needs to be protected for a long time. So it means I need more persistence. Or I'm completely short-lived application and I just want to work on a data set and forget about it once I die. So it means applications can actually provide hints by the form of labels. And what we can do at Datera end, whenever we come across any of these hints, we react to those. So in the layer, what we have built at Datera storage system, we have labeled every resource that we have in the system. So be it like storage or a node or a policy or a behavior. Every time an application comes from the top and passes a hint down, we automatically bind the resources based on the hints that you have given. So if somebody has asked for more performance, by the virtue of receiving the information from the application framework that this application is performance savvy, we basically pick up the nodes which are having a better media quality to place the data on. So that basically guarantees that how your application has wanted resources, we have bound those resources for you.
That's mapping to policy names?
That's mapping to policy names, yes. At the same time, that also maps to like it just not be policy.
So it can be dynamic, like you were saying, it looks around at the nodes and says, these are SS flash heavy.
Absolutely. So there are multiple ways. So if since our discussion we are using Kubernetes very heavily, so if I take a liberty of an example, if a
Class attribute?
yes,
Okay.
storage class attribute, right? So
Yep.
that's precisely the one. So when you talk about an application which needs a storage resource, you're binding it to a storage class, and through a storage class you can say, okay, hey, this storage class is for heavy performance, let's say gold performance as such, and the storage class itself would create the resources in the Kubernetes world, which is like PVC, which is called persistent volume claim, which in turn will be using our driver and mapping and basically passing these hints down to Datera fabric, saying, okay, hey, this comes from a storage class, which is a performance savvy class, and that's where we'll make sure, okay, you get your data placed onto high performing tier.
And you can map just about any of the storage class attributes to some Datera storage someplace in the cluster. Is that how this would work?
So yes. Important thing is, since we're already talking about it, storage classes are just the way to communicate that how your storage requirements, storage resources need to be bound.
System volume,
right?
claim, persistent
Right.
volume, yeah.
Exactly. So, but underneath, the fabric is common. So the storage resources, the whole point what I was making about why your application should not be worrying about your physical resources underneath, that's primarily because of this. Because application users and application designers, they do not really care about where they run, right? They are running on just abstract resources. All you have done is basically you have somehow labeled these resources and presented back to the framework saying, okay, I have these available. You very well can say, okay, I have a banana performance storage and I have an apple performance storage. And if an application vendor somehow thinks the same language as same protocol as you think, you can say, okay, I want to run my storage. I want to run this application which has a label as banana storage. That banana can map to an opt-in node underneath, but the application vendor doesn't care about it because they only care about the resources. And tomorrow that opt-in mapping of banana storage changes to, let's say, lower performant media, so be it. So the point is, when storage resources are common, these frameworks actually map the applications down into these storage components based on the requirements you have set across. But the storage fabric is still common across. So when you talk about typical isolation and all those things, that's where you define the boundaries that you want a physical barrier, like providing a failure domain or a storage pool or other kind of things, or you still continue to want to have the segmentation based on the layer on the top, like your iSCSI and other things.
Yeah. 3 minutes.
So at Datera, as I talked about, like we define resources and we basically define the policies. Okay, policies are the one which actually binds your application and the resources together. Applications are allocated resources based on the type of hint they have passed, and system underneath has a small process which is running like an optimization process, which constantly moves the data, places your resources in such a way that it's getting the finest balance as you require for the performance point of view. Now, if you take this model a little bit, I think we just talked about it, in a public cloud, like typically when people are provisioning applications, what is really happening is you're introducing an application, you're putting your resource requirements, and there is a resource manager kind of a layer sitting somewhere which knows about the resources that are available. And as your application poses in the requirement for the resources, there's a process which actually matches what you need, and it basically allocates those resources for your application. Your application consumes those resources. Once the application is done, resources go back. At Datera, we exactly do the same thing, but a little better fashion, because now our resources are dynamically managed, because whenever a node is added or a node is gone, we basically automatically pull the resources into the whole resource manager. Now we have the complete inventory, what do we have, and how do we label them, and basically we know exactly each and every part of it. When an application requirement comes from the top, we can match these resources at a very granular steps. And this whole process keep working along with the things. So since we have taken a lot of decisions out of, we have taken a lot of complexity out of your process of thinking while you're designing your application, we actually let you choose your difficulty level at Datera. Or rather, we'll say, okay, we'll let you choose how simplified you want your life to be when you deal with the Datera fabric. So we let you define templates, which are basically a very niche way of maturing your skeleton. So once you have worked with an application, you figure out, okay, these are the things that work with me. I say, okay, this is my gold definition. I'm going to name it as a template. So template is nothing except a set of behaviors packaged together. They could be a data placement mechanism. They could be a data protection mechanism. They could be your IP pools and other things. But you have actually packaged this behavior together into a single entity, and you have named it. Now, once these tenants are defined, these templates are defined, you can actually point to these templates in your storage classes, as we talked about in the Kubernetes world. But you can also make the changes to these templates. So any of the applications that you have created using these templates automatically receive an update when a template is changed. So it means your deployment, once it is actively running, you are not logged into the initial definition that you put in. You still can tune in your environment based on what you are doing. Users are exposed to details based on their role. So you can very well define a lot of users in the system, and you can say, okay, these users can only change the snapshot schedules, or these users can only go and create templates. These users can only tune in these policies. So you basically choose that which user can perform what operation and at what level. It brings a lot of simplicity and consistency to multi-user environment, because typically in an environment where, in a typical environment where you have like applications which are scaling out and you have multiple of those instances running in, you definitely want to have control in your hands that anytime you scale out, your environment still remain consistent. Like typically an application like stateful set in Kubernetes and other places where more and more replicas are coming in, you got to make sure that all those replicas are following the same pattern as your initial applications are. And that's where Datera gives you tremendous control by mapping those into the same templates using storage classes and other things.
So what customers are your target customers? What sort of customers are you going for? Because this is great for those customers who've moved on and deciding to redevelop their applications, but we know that storage gets replaced faster than applications do. Typically, you're not rewriting your application every 3 years, perhaps.
That's a great question. So, we went through the process with a Midwest financial customer. They were running Tier 1 enterprise array. They had an expectation around performance, latency, availability. They wanted to change their cost basis. Mm-hmm. So they started looking in the marketplace, and they found our technology. They put us through the ringer in regards to the testing process. And their comment was, this technology on commodity servers is fast enough via iSCSI with whatever network, layer 2, layer 3, that they can take that application and run it, do nothing. But when I'm talking to them, they're thinking about 5 steps down the road. How do I get there?
Absolutely, yeah.
So that's the magic. The customers that say, we need to modernize, I'm looking to change my cost basis, I'm looking to change what I do today without giving up what I'm doing. I want to take what I have, do it on this, but then open up all this other capability so that as I'm building out a self-service database farm on Kubernetes, I don't have to do another vendor selection.
So would you say you're coming in usually when people are doing hardware refreshes, or are you coming in as part of we have this new plan, new type of application? Are you coming in more, we're saying, it's a refresh, we can get in there and compete with everyone else and show them how good you are and give them a future roadmap? That's the real the core market?
Yeah, it is. I mean, some of the customers we talk to have competitive technology. And we sit down with them for lunch and we describe what we do, and then we get a proof of concept. Some of the customers are on this journey. They want to modernize. They recognize that having 100,000 fiber channel ports is great for availability, but it's a little rough on the pocketbook as they think 5 years out. And they look at 100 gig, 400 gig Ethernet, and they look at 32 gig fiber. Nothing against any of the technologies, but it's a little cheaper now to go 100 gig Ethernet. These are all the vectors that people come to us and say, I have multiple problems. One, I need to get more agile, whether it's today or in the future. I want to stop evaluating a new vendor every time someone says, I have a shiny widget and your thing can't do it. Because our technology, I have Optane running in my lab. One of the wonderful things about storage people is they get blamed for everything. It's slow. It's the storage guy's fault. It's like,
I always blame the network people.
Right.
well, you point fingers. But when you're in the room, like, I have the
Everybody does.
fastest persistent memory on the planet. I put your application on it, and it didn't make a difference. Let me show you how the latency is, and your application is still running at 4 seconds.
This is what-
It's not this.
This is where we go. It's the all-flash array is the mean time to innocence for the storage and memory.
So
I like that.
I have a concern.
Yeah.
I totally get it, and it works. Okay, so I agree with you on everything. No, my only concern is that when you build one of these applications, most of the IOPS don't happen at the Kubernetes level, because they, even storage for containers was an afterthought.
Yes.
Okay.
Still is.
So, if I build my Cassandra database that will lead my huge website, probably it's bare metal. Or even if I'm using your technology, all these thing about changing on the fly, the template and QoS, I'm not sure that there is too much of a differentiator there. Yes, you can have a few applications that need a lot of IOPS or a few containers, but actually my thousands of containers, so thousands of servers running on Cassandra, they always need all the performance that they can deliver.
Sure.
So
but how do you back it up?
every storage that can give me again all of the performance and give me based performance, whatever, it's good enough. In fact, we have more and more people going back to bare metal with this application. Scale out application don't need actually all of the storage.
Okay.
Because all the application already manages everything.
Yeah, so a lot of Cassandras run on Amazon. A lot of that's run on EBS. EBS is shared storage. So there's an argument to say, for some applications, they offer data services. That's what it is. They do their own replication, but those data services tend to be relatively primitive. They don't really snapshot. They don't have a good integration into backup technologies. Customers come to us and say, I got a large NoSQL farm. How do I back this up? I can't. Right? Or they get into the situation of my utilization is very wonky because I'm putting in this amount of NVMe in all of my servers and I'm not getting good utilization. That's a valid problem. Or they say, I have a bunch of different applications. I got Postgres, I got MySQL, I got Oracle, and now I have Cassandra. How do I, as a storage team, help those customers be successful?
Okay.
So it's a fair point around the levels of optimization. That these new NoSQL applications have data services built in, and they can operate and manage that host by itself. But if you start thinking about how do I deliver that as a service? How do I produce an environment to bring me the agility? Because that is a silo. You can silo all day long. And if you want to run your organization as a silo, great. If you want to have a consistent data storage API, where no matter what your application is, no matter where it is in your enterprise, it's the same API call, even though it could be radically different hardware, that's what we offer. That we can provide backup, we can provide snapshots, we can provide replication technologies, all that kind of stuff.